Hi, good day, and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your maths facilitators, and today I will be exploring factorization. My name is Joseph Frederick. Now, before we look at factorization, I just want us to take a look at where we have been and where we intend to go. So under algebra, we started off with our first or second video doing some introduction. After that introduction, we went on to look at binary principles or binary operations and the distributive law. So following that, we intend to look at factorization. That's what we want to look at today. However, we want to break up that exploration of factorization into two parts. So today, we are going to do that first part. After we have completed factorization, we shall go on to look at algebraic fractions and then at equations and inequations. And that would complete for us our basic algebra. There's much more to come in algebra. So keep looking at these videos and let's have some maths fun. So back to what we are here about in this video. In this video, we are looking at factorization. Now, our objectives here are, at the end of this video, you should be able to appreciate the use of factors in algebra, evaluate algebraic expressions to determine the factorization method needed to factorize it, and factorize expressions using any of the following: the distributive property, grouping, and the differences of two squares. So this is what we want to complete for this video. Let's begin. So, firstly, we are looking at factorization. The root word for factorization is factors. Yes, I know some English. Yes, I do. So the root word of factorization is factors. What are factors? We are saying that factors are numbers that we multiply to get another number. Let's see what that is really saying. So here we have the number 24. And based on our definition of factors, we are saying that these are numbers we multiply to get another number. So then the question is, if we are looking for factors, what numbers can we multiply to get 24? Can you think of any? Now, here are the numbers that I got. I got that here is what? 8 multiplied by 3 is 24. Now, remember this, that in any exploration of mathematics, your tables are important. If you don't know your tables, that is okay. But what is not okay is for you to not know and keep not knowing. So if you don't know your tables, please start learning your tables. It's very important in your exploration of mathematics and your mathematical success. So here we're saying that factors are numbers that can be multiplied to give us another number. Here we have that 8 and 3 can be multiplied to give us 24. Likewise, can you think of any others? Likewise, 24 and 1, yes. 1 time any number is that number. So 1 time 24 is going to give us 24. Can you think of any others? Here, 12 times 2. 12 times 2 is 24. Can you think of any others? I think I have one more. 6 times 4 is 24. So all of these numbers here can be multiplied to give us 24. Therefore, we can conclude here that the factors of 24 are all of these numbers. 1, 2, 3, 4, 6, 8, 12, 24. All of these numbers are the factors of 24. So I hope you now have a better understanding of what factors are, because we are going to look at factorization, and this here is going to be very important. Now, hear this. These here are factors of numbers that you may know already. But here we are looking at algebra. And so when we speak to factors, we are speaking of factors of algebraic terms or algebraic expressions. So can we utilize this construct that factors are numbers we multiply to get another number to get the factors of some algebraic terms? Look at this one here, x cubed. In our previous video, when we were looking at multiplication and division of algebraic terms, we did develop that concept for multiplying, or what these powers mean. We said that these powers here indicate that whatever this base is, we call this here the base. Whatever this base is, this is our base. Whatever this base is, that's our base. Whatever that base is, the power, this here is our power. That power tells us, the number of times that the base has to be multiplied by itself. So therefore, we know for sure that x cubed is going to be x multiplied by x multiplied by x. So therefore, one factor of x cubed, x multiplied by x multiplied by x, one factor of x cubed is of course going to be x, because x is something that is multiplied or can be multiplied to give us x cubed. Can you think of any other factors? What can we multiply to give us x cubed? What if we decided to group these two here together? X by x. X by x here is going to give us x squared. Yes? And then it's going to be multiplied by x. So, x squared multiplied by x gives me x cubed. And based on a definition of factors, these two would have to be factors as well. Can you think of any other factors? Here are some more factors. We are saying here, let me just use my eraser for a bit so that we see it a bit clear. We are saying here, that the factors of x cubed, remember we said 1 multiplied by any number is going to give us that same number itself. 1 times 5 is 5, 1 times 12 is 12, 12 times 1 is 12, 20 times 1 is 20. So 1 multiplied by any number, it also applies to algebra as well. 1 multiplied by any term is going to give you back that term. So 1 multiplied by x cubed is going to be x cubed. What about this one? We looked at this one already. We said x multiplied by x is going to give us x cubed. If you don't fully understand why, please check out the video that we did on operations involving algebra. It will give you the guide to better understand this. So we said x cubed is x multiplied by x squared. So therefore, here, x is going to be a factor. X squared is going to be a factor because these here are multiplied to give us x cubed. So let's see what again. Well, we looked at this already. X multiplied by x multiplied by x. So x cubed can be 1 times x cubed. X cubed can be x multiplied by x squared. X cubed can be x multiplied by x multiplied by x. When listing the factors, we only list them once. So the factors of x cubed, are, what are the factors of x cubed? The factors of x cubed are x cubed, x squared, x, and 1. Now bear in mind that, just doing this little recap for you with multiplication, that the bases must be the same. So when we are looking at the factors of x cubed, the bases here must be the same. And what are our bases? This is my base, this is my base, this is my base. So the bases across here has to be the same as well. What is the base here? What is the base here? And remember, when we are multiplying, if I'm looking for factors of x cubed, the bases have to be the same. And when I'm multiplying, I'm adding the powers. So the question is, what powers do I add here to give me this power 3? We did speak to 1, and we're going to look at him as we go on into some more advanced algebra. But for now, we'll leave him here, and we'll continue on. So the factors of x cubed are x cubed, x squared, x, and 1. So, can we now, we looked at what we looked at before. We looked at the factors of 24. Yes? We also looked at the factors of x cubed. Now what we want to do here is that we want to combine them via multiplication. And we want to determine what are the factors now of 24x cubed. Now, recall for me that we said the factors of 24 were 1, 2, 3, 4, 6, 8, 12, and 24. We also said that the factors of x cubed were 1x, x squared, x cubed. So if we now want the factors of 24x cubed, what we are going to do, because we have combined 24 to x cubed, what we are going to do is that we're going to combine one factor from 24 to one factor from x cubed. So here, I could say one factor of this is going to be, take a number from here. A number from here, what, 4? Right? 4 and what? Take one from here too. 4 what? 4x is going to be a factor of 24x cubed. Likewise, take another number here. We take 12. 12x squared is going to be a factor of 24x cubed. What again? Let's look at another one. So what we are saying here is this, that once we know the factors, this here is called the coefficient. Once we know the factors of the coefficient, We can then utilize those factors and combine those factors with the factors of the variables to create our factors of our, I would call this here our compound term. So it's a combination of a coefficient and a variable raised to a power. So for us to get the factors of that, we are going to combine the factors of the coefficient to the factors of the variables. And that's what we do to get our factors of any term in algebra. Once you know factors of coefficients and factors of variables, you just combine them and you get the factors of your algebraic term. So we looked at factors. The next thing we need to look at now is the highest common factor. How do we determine hold for me. How do we determine, or should I be asking, what is the highest common factor? So that's the first thing we need to do. Remember what we said when we started off our exploration here in these videos. We said anything that you are going to explore in mathematics or any subject matter, you need to first know what it is. So we looked at factors. We came up with a definition of factors. Now we are moving on to highest common factor. We need to understand exactly what it is before we can develop that concept. So what do we mean when we say highest common factor? We are saying that the highest common factor, this is the biggest, the highest, the largest factor of the stated term or the terms in an expression. So what we need to do now is that we need to look at an expression. And in that expression, an expression would be made up of terms. We looked at that in a previous video. If you have forgotten, please check that previous video. So we looked at an expression being made up of terms. And we are saying that the highest common factor is the biggest, the largest factor of the terms in that expression. So let's see what that means here. To get the highest common factor of 3x squared and 6x. So here we have some terms. We have the term 3x squared and we have the term 6x. We want to get the highest common factor. How would we do that? Now, back in primary school, and I'm hoping that you remember your primary school days. My best time in primary school was when I had to line up for that lovely school feeding. It was one of the most amazing experiences I had. But to find the highest common factor of some numbers, what you would do is that you would write that number as a product of its prime factors. So look 6 here, for example. What are the prime factors of 6? Can we write 6 as a product of its prime factors? Correct is right. That is going to be 2 by 3. And what about 3? Well, 3 is a prime number. What is a prime number again? A prime number is any number that can only be divided by itself and 1. You remember that? Yeah, that's right. So 3 is a prime number, a product of its prime factors. So if we are looking for the highest common factor of 6 and 3, then that is going to be what is common here. What is common is 3. Now, it's important for us to explore these terms. It's the highest. So yes, a number may have multiple factors. We are looking for the highest factor. That is common. Yes? To all the numbers that you may be given, or we are doing algebra, that is common to all the terms that you are given. And again, we are looking for factors. That's right. So we want to now utilize this construct from primary school to create the highest common factors of 3x squared and 6x. Well, we already said that 3 is 3 as a product of its prime factors, and 6 is 2 times 3 as a product of its prime factors. So now, if I want to get here 6x, then 6x is going to be, this gives me 6. Yes, we have that already. And now we want 6x. So remember what we said. 6x is 6 multiplied by x. So this is going to be 2 times 3 is 6 multiplied by x is going to give me 6x. Now for the other one, we want 3x squared. How do we get 3x squared? 3x squared is 3x squared, yes. And we already said that 3 is prime. And we need now to get 3x squared. 3x squared is 3 multiplied by x squared. But what is x squared? Remember that video we did with multiplication of algebraic terms? X squared is really x multiplied by x. And we are looking for the highest common factor. Back in primary school, circle what is common. We already circled him. 2 is not common. x, I'm seeing x being common in both of them. So I'm going to be circling my x's. Circle my x's, x is common here. There's a second x in 3x squared, but there's no second x in 6x. So that is not common. A second x is not common to all of them. So therefore, what we are left with as being common, it's 3 and x. They're both being multiplied, so it's 3 multiplied by x, giving us a highest common factor here of 3x. Let's check and see if that was correct. Let's see. We can write the terms in expanded format. Did we do that? Yes, we did. All right. And then we selected what was common. 3 is common and x is common, giving us the highest common factor is 3 times x, which gives us 3x. I see my writing is blocking you slightly. Let me just erase my writing there. So our highest common factor here is 3x. The highest common factor is for each variable, the contributor to the highest common factor is always, I put it in red, it's always the one with the lowest exponent. What is exponent again? Exponent is the same as power. So the contributor for each variable to the highest common factor is always the one with the lowest power or exponent. So look here at our example. We are looking here at 3m squared n fifth and 5m cubed n fourth. We want to determine the highest common factor. Now this is what I recommend you do. What I recommend you do in determining the highest common factor is you start from the left, the number on the left, you start there. And you look at that and determine if it has common factors throughout the expression or for the other terms that you are considering. So here, the first thing I have here is 3. Let me use a different color. The first thing I have here is 3. That's my coefficient. So what I'm going to do is I'm going to look at the other coefficients in my expression and determine if there's a common factor. So here, this coefficient here for this term is 3. For this one, it's 5. 3 and 5. Do they have common factors? No. 3 is a prime number. 5 is a prime number. Well, let's not say no. We should say, do they have common factors outside of 1? Because 1 is a factor of any number that you may know. So for 3 and 5, do they have common factors outside of 1? The answer is no. So here, what we are going to use here, our contributor in terms of 3 and 5, our contributor, we don't usually write it, but our contributor here is going to be 1. So 1 is a factor of any number. So we usually don't look for 1. We look for numbers that are greater than 1 for common factors. If we can't find any, then we just use our default. 1 is a factor of any number. Then we go, as I said, we start from left and we're coming in. After the 3, we have m for this term. So what we do is that we check the next term because it has to be common. It's the highest common factor. It has to be common. So this has m. Does this have m as a variable? Yes, they do. Now, according to our rule of thumb here, we are saying that for each variable, the contributor to the highest common factor is always the one with the lowest exponent. So here, this m here has a power of 2. This m here has a power of 3. The contributor is always the one with the lowest power. The one with the lowest power here is 2. So it's going to be m2 or m squared. We come again. So we have done our coefficients. We have done our m's. We move to the next one along the line. The next one is what? N. So for our n's, what contributes to the highest common factor? Is it common firstly? Yes, it is common. I see n here and I see n here. This is n to the power 5. This is n to the power 4. The contributor to the highest common factor, again, our rule of thumb here, the contributor to the highest common factor is always the one with the lowest power. So, in terms of my n's, who has the lowest power? It is n4. So it's going to be 1m squared, n to the power 4. And that's our highest common factor. I'm going to give you an opportunity now to find the highest common factor of some expressions. Or terms in some expressions. So look here. 10x cubed y squared, 5x squared y. what is the highest common factor of these two terms? Take some time. Tell me what you think. Right, so we're back. So here we are saying that what we shall do, yes, you can do the expanded format, you can expand it, but that takes too long. We are trying to understand maths, but also understand some of the shortcuts that we can utilize in mathematics. So what we do is that we do an analysis of our coefficients. Look at your coefficient. The coefficient here is 10. The coefficient here is 5. 10 and 5, do they have a common factor? Is there a number that can be multiplied by some other number to give us 10, and that same number multiplied by another number to give us 5? Yeah, that's correct. It is 5. So here, 5 is the contributor to my highest common factor for my coefficients. We then look at our variables, doing a variable analysis, variable by variable. After the 10, we have x cubed. Let's check. Is x common in both terms? This is x cubed. Yes, there's an x here as well. So x is common. We did say that the contributor to the highest common factor is the one with the lowest power. So here it is going to be x squared, the one with the lowest power in terms of x's. And let's look at our y's. We have here y squared here and y here. Is y common? Yes, y is common. The contributor is the one with the lowest power. Wait 1 minute. I am seeing y to the power 2 here, but I'm seeing y and no power. If there is no power, then what? Now remember, when we were doing multiplication, we did say no power on an algebraic variable says to us that the power of that variable is 1. It does not mean that the variable is equal to 1. The power is 1. So we are looking here now in terms of our y's for the one with the lowest power. The one with the lowest power here is y to the power 1. Remember, we don't usually write that 1. So highest common factor here is really 5x squared y. We take a break and we shall be right back. Right, so we're saying that the highest common factor here is 5x squared y. Wait, I wrote the 1 again. Watch here. Don't worry, it doesn't make it wrong. It's just that convention in mathematics indicates that we should not write that 1, it's understood, so it's 5x squared y. The 1 is understood, so we don't have to write that 1. So let's look at another one. Look at this one. Try this one for me. Oh, I'm blocking you again. Sorry. Right. So let me not block you. Let me erase it here. Tell me if you've seen it now. Are you seeing it? Right. So, look at this one. A squared, b cubed, and try to get accustomed to some of the terminologies in mathematics. This is a squared, not a2. This is b cubed, not b3. So try to get accustomed to it. And you know, you're going down the road, hey, a squared, that a squared looks nice. Yes? It sometimes make you lots of friends, I think. Right, so we're going a squared b cubed c and a b squared e cubed. We want to get the highest common factor. Wait 1 minute. In the one before, I knew that the coefficient was 10 here, the coefficient was 5 here. But what is the coefficient here? There are no coefficients. Something is wrong with this problem? No, not at all. We have stated in a previous video, please check that video. We have stated in a previous video that coefficients still exist. That coefficient is 1. If I see no coefficient or no number in front of my term, a number still exists. That number is 1. So this is 1 here, and this is 1 here. Both of them have 1, so we know that the contributor to the highest common factor is surely, for the coefficients, it's surely going to be 1. Let's move along. So here, after that 1, we have a squared on this one. We need to check to see if a is common. If it is not common, then it cannot contribute to the highest common factor if it is not common. So let's check and see if my a is common. Here I have a squared. Do I have any a's across here? Yes, I do have an a across here. Now again, we looked at it in this case, that if I see no power, a power still exists. There's a power here on this a, that power is 1. It looks joined up there. There's a power here on this a, and that power is 1. Right. So now, you remember what we said? The contributor to the highest common factor is that variable, for that variable itself. Here we're looking at the variable A. For that variable, the contributor to the highest common factor is always going to be the one with the lowest power. The lowest power here is a to the power 1. And we have finished with our A's. We now move on to the next variable. Moving on to our next variable here, and we see B. It's B to the power 3 or B cubed. Is B common? Let's check across here. Yes, B is common. So B is going to contribute to the highest common factor. What about B will contribute to the highest common factor? Rule of thumb, it is always the one with the lowest power. The lowest power here is 2. So that is going to be B to the power 2. Now, coming across here, we see we have C. Is C common? In order to contribute to the highest common factor, you must be common. C is not common, so he cannot contribute to the highest common factor. Have we checked all the variables? Let's see. We looked at our coefficients, we looked at our A's, he contributes. We looked at our B's, he contributes. This seems somewhat like working in a group. You know, in a group, some people contribute and some people don't. This seems like working in a group sometimes. But let's see, well, who contributes here? So we said that the B contributes. The C doesn't because he's not common. But we missed out someone, the E. Does the E contribute to the highest common factor? No, of course not. It has to be common. It is highest, must be the highest, and it has to be common to all of them. And it must be a factor. So it's highest common factor. So the highest common factor here now is 1, A to the 1, B to the 2, or let's say mathematically. It is 1A, B squared. So the highest common factor here is 1AB squared. You are right. I'm not saying it mathematically at all because I said the 1. I should be saying it is simply AB squared. Let's look at another one. I love this. Factors and highest common factor seems to be a very exciting topic. I like this topic. Do you? So let's look here. Let me make some space for you to see. Make some space for you to see. All right, you seeing this here? Nice. Now, I must say that, this COVID experience, this corona experience has proven to be an interesting one. You have to stay indoors and find exciting things to do. And whoops, there pops up mathematics, one of the most exciting things that you can do. So try some mathematics while you're at home. Let's look at another one. 2m squared n squared p and 3m4 n squared p squared. What is the highest common factor here? Again, we are going to do the analysis step by step. Look, so don't try to just look at it and, highest common factor. No, it sometimes frustrates you. Do it step by step. Do the coefficients first, then do variable by variable until you have completed the entire term. I know we maths people, we like to use a lot of shortcuts, but as we get to that space where we can use as many shortcuts as possible, we must take our times to understand the concepts. So take your time, understand the concepts. Let's go. So here, coefficients. My coefficients here are, hold for me. I didn't get my pen, I had my eraser. My coefficients here are 2 and 3. Common? Of course. Common factor, there's none outside of 1. So we're going to write the highest common factor here. Highest common factor here is 1. You're correct, is right. You evaluated your m's? Of course you did. The one with the lowest power, m squared. You evaluated your n's? Of course. Well, look here. Both n's have the same power. What then do you do? Just use that same power. It is n squared. It's the lowest and the highest. What about my p's? Again, remember, if I see no power, there's still a power here. That power is 1. So this here, the one with the lowest power is going to be p to the 1. Writing it like mathematicians now, we write, it is going to be m squared n squared p. How about that? You like that? I like that. Look at this one though. This one is for you. This one is for you. I'll leave that one. This one is too easy. This one is for you. Look at this one. Tell me, how do we get the highest common factor? Of course, we do the same thing. Of course, it's a fraction, so we know for sure the vinculum, we need to get that vinculum. And the highest common factor, do the analysis as we have been doing it before. step by step, do the coefficients first. In terms of my coefficients in my numerator, it is 9, it is 3, it is 6. Yeah? So we go. Highest common factor there is going to be? Correct is right. That is 3. What about my m's? This is m to the power 3, m to the power 2. M, no power means the power is 1. It does not mean that m is 1. The power on m, the exponent there, is 1. So, the contributor, remember what we said? The contributor to the highest common factor is the one with the lowest power. The lowest power for my m's here is going to be m to the power 1. Correct is right. So here, the highest common factor we're looking for. Now we did what? We did our coefficients, we did our m's. We need to move on to our n's. We're focusing at the numerator. So in terms of our n's, this is n squared, n cubed. Again, the contributor to the highest common factor is the one with the lowest power. Initially, it's going to be a little tricky because we are looking for the highest common factor, but the contributor is the one with the lowest power. So initially, it's going to be a little tricky. So the highest common factor here is 3m for my m's contributor. For my n's, it's going to be n squared. Correct is right. And how we finish with our numerator. Yes, we are finished with our numerator. We then go to our denominator. In our denominator, what do we have? We have p to the 5th, p, and p cubed. What is the contributor to our highest common factor there? Of course, the one with the lowest power. The lowest power here is p to the, that's right. So it's 3m to the 1, n squared, p. That is our highest common factor. So I hope now you can look at the exercises that I shall be sending to you, that you look at those exercises and you can then evaluate what the highest common factor is. We want to move on a bit now. So let's move on. We want to look at factorizing utilizing the distributive property. Now, I want you to recall from our previous video, remember to check it out, recall from our previous video that 7 brackets x plus y is 7 multiplied by x plus y, and that the 7 is the coefficient, but it's also the common factor because it's being multiplied by the 7 and it's being multiplied by the y via the distributive property. So it's 7x and 7y. So the common factor here for these two is going to be 7. Yeah? We want to utilize that construct as we go forward, exploring the distributive property and factorization.